In this section, 1.3, we're going to talk about problem solving. What you will learn in this section is problem solving techniques of looking at word problems and applications. George Polya, a mathematician who was educated in Europe and taught at Stanford, developed a general procedure for solving problems. Guidelines for problem solving is understand the problem, devise a plan to solve the problem, carry out the plan, and check the results. In understanding the problem, we read the problem carefully at least twice, determine the type of problem, whether it's geometric, money, mixture, or motion, try to make a sketch or draw the problem, put the information given, draw or put the information into a table, make a list of the given facts that are pertinent to the problem, determine if you have sufficient information to solve the problem. In devising a plan to solve the problem, you can relate this problem to a previous problem that you've worked before. You can express the problem in terms of an algebraic equation. We can look for patterns or relationships. You can express the problem more simply. What is the strategy? That is the key. So after we find the type of problem that we're dealing with, and we draw out or we put the information in a table, we want to determine the strategy of the problem. You can always substitute smaller or simpler numbers to make the problem more understandable. You can list the information in a table to help solve the problem. You can make an educated guess by trial and error, or you can work the problem backwards to determine the correct procedure. So, once you know the type of problem you have, and you have a table or a drawing, and you figure out what the strategy is, now you carry out the plan. Finally, we ask ourselves, does the answer make sense? Is it reasonable? If the answer is not reasonable, you recheck your methods for solving the problem in your calculations. Can you check the solution using the original statements? Are there alternative methods to arrive at the same conclusion? Can the result of the problem be used to solve other problems? So in example 2, Shuttle Revenue, an airport express shuttle service provides service from San Antonio International Airport to downtown hotels, approximately 10 miles away. One particular shuttle makes 16 round trips per day and carries 5 passengers per trip. The fare for each way is $18. What is the receipt from one day's operation for this particular shuttle? In this case, the type of problem that we're looking for is money or revenue. And in this case, we want to know how much. So we make kind of a table. The distance from the airport to downtown hotels is 10 miles. The number of round trips per day is 16. The number of passengers per trip is 5. The fare each way is 16. So our round trip cost is $36, and the total receipt for one day is the product of the number of round trips, the number of passengers, and the cost per trip. So we have the number of trips, the number of passengers, and the cost. And we multiply it all together, and we see the solution is $2,880. question is, does it make sense? I believe so. Because if we go back, we know we have how many round trips? 16. We have 5 passengers per trip, and we have a total of $36 per round trip. The next question, is it never too early to start planning for retirement? The U.S. Census Bureau data indicates that at the age of 65, the average woman will live another 20 years, and the average man will live another 17.2 years. The data also indicates that about 33% of the average person's retirement income will only come from Social Security. When discussing retirement planning, many investment firms and financial planners use a graph in the figure on the next slide, which shows how long a typical retiree's assets, or nest egg, will last based on the percentage of the assets withdrawn each year. So you can see from this graph how much will annually affect your money. If you're going to withdraw 10% of your savings per year, you only have 11 years of that savings. If you do 9%, it's 13, and if you go all the way down to 4%, it can last approximately 33 years. If a typical retiree has a retirement asset of $500,000, how much can he or she withdraw annually if he or she wishes the assets to last 21 years? So in this case, the type of problem that we have, again, is money. And again, we're asked how much. Right? So we go back and we say, oh, well, what are the issues here? Okay. The first thing is we look at 21 years. We want it to last 21 years, so we see that 6% can be withdrawn from the assets annually. So from the graph, we can see that the assets to last 21 years is about 6%. And we're withdrawing annually. The amount that can be withdrawn is the amount of assets, the amount of assets at 6%. So we multiply 0.06 times 500,000, and we see it's approximately 30,000 per year. So in this particular case, we would get $30,000 of money per year at 6%. The next question is how much should a retiree have in assets if he or she wishes to withdraw $25,000 annually and wishes to have his or her assets to last 18 years? So again, we go back to the chart of how long it will take to last for your assets to last. So we come here at 18 years and we see 7%. So the graph of assets lasting 18 years, about 7%, is withdrawn annually. That amount has to equal 25,000 of assets. And so we set up the process. The strategy is the percent, right, times the asset is equal to the amount. In this case, the percent was 7%. The assets we'll call as X, and the amount was $25,000. So now to solve for X, it's just 25,000 divided by 0.07. This was our strategy. Right here's our strategy. And so when we find that out, we find that the solution is this amount, 357,142.86 needs to be our assets. The cost of Freddy Rojo's meal before tax is $28. If a 6.5% sales tax is added to his bill, determine the total cost of the meal including the tax. So this again is a money problem, but now we have 6.5% of the meal is going to be the sales tax. So we multiply the percentage times the total cost of the meal, and we see that the tax is $1.82. So the total bill is equal to the cost of the meal plus the sales tax. This is our strategy right here, right? And our strategy is always the same for other problems with sales tax. So the total bill is $628 or $28 plus 1.82, which is $29.82. So that's our total bill. Now, if Freddie wants to leave a 10% tip on the pre-tax cost of the meal, how much should he leave? To find 10% of any number, we multiply the number by 0.10. So the cost, the pre-tax cost would be 0.10 times 28. It would be $2.80, right? So a simple way to find the 10% is just move the decimal point to the left 1. Now Freddie knows that he wants to really leave a 15% tip on the pre-tax cost of the meal. How much should he leave? So to find the 15% of 28, he can multiply 15% times 28, which is 0.15 times 28, which is $4.20. If he doesn't have a calculator, he can first find the 10% amount and then just add half of the 10% amount on to make the 5%. So it's 2.80 plus a half of 2.80, which is 280 plus 140, which is 420. So our next example is the instructions on the Ortho Weed Be Gone lawn weed killer indicate that to cover 1,000 square feet of lawn, 20 teaspoons of the weed killer should be mixed in 5 gallons of water. Ron Haynes wishes to spray his lawn with the weed killer using his pressurized sprayer. How much weed killer should be mixed with 8 gallons of water to get a solution of the proper strength? So the type of problem here is mixture. And in this case, we're saying not only how much, but what proportion, what's the proper strength. So this is a ratio problem. So here's the solution. We use 20 teaspoons of weed killer is to be mixed with 5 gallons of water. There's our ratio, 20 teaspoons to 5 gallons of water. And now we want to say, okay, he has 8 gallons of water. How many teaspoons does he need? Right? So we have teaspoons to teaspoons, gallons to gallons. This is a ratio problem, right? And of course, as always, we can replace X up here as our quantity to find out. And again, we're going to cross multiply. So here's our original problem. When we cross multiply, we get something that looks like this. 20 times 8 is equal to 5x. Now, of course, we get 160 is equal to 5x, and we divide both sides by 5. and we get 32 teaspoons of weed killer that needs to be mixed with 8 gallons of water, right? The instructions on the Ortho Weed Gone Lawn Weed Killer indicates to cover 1,000 square feet of lawn with 20 teaspoons of the weed killer should be mixed with 5 gallons of water. But Ron wishes to spray his lawn with the weed killer using the pressurized sprayer. How much weed killer is needed to cover an area of 2,820 square feet of lawn? So again, this is a ratio problem, but now we know we have 20 teaspoons for 1,000 square feet with 5 gallons. And now we want to know how many teaspoons that I need to find, right? So again, I replace the number of teaspoons with X, right? So there's our strategy. And finally, here's how we set up the problem. And we do the cross multiplication. We end up with 1,000 X is equal to 56,400. We divide that by 1,000, and we, of course, get 56.4 teaspoons. Now, this is not going to be satisfactory. We then have to go back and find out how many gallons of water we need, because the ultimate setup, obviously, is 20 to 5 is equal to 56.4 to X. And when we solve that problem, we'll find out how many gallons we'll need of the teaspoons mixture to actually do the final job. Well, that concludes our problem-solving methodologies. We're going to talk more about this in class, and we want you to work as many problems as possible to get the feel for this section.